Hello, Jeremy. Hello, Matt.
Hello.
Hello.
Hey.
She said that she knew I had some cash and the money in the account, but she didn't know exactly how much. But she hasn't given me back to me.
So we did the magnetic field for a circular wire as much. I think I gave a reasonable picture of how you get the magnetic field of it. How was the homework, by the way? Was it too lengthy or anything?
I wasn't able to get the same as we got in class using the expansion method. I mean, it was kind of close, but it wasn't.
Okay. Anyone else? Everyone struggled?
It was a little tough.
Yeah.
Curtis?
It was okay. Like the second part for number 2, kind of, I didn't get quite the right answer, I think, but I got
So
pretty close.
no one got the correct answer. So I think the last one where the approximation leads to that. Yeah, I know that it's a little tricky, but just follow the algebra. That's what typically happens. But you have to keep the right order. K raised to 4, I suggested that. You think it'll benefit if we do that now? Yeah.
Or if you even had like a solution you could post, maybe that we could just look through.
Which one do you prefer?
Either one.
Yeah.
Okay, let me see. I can, since you guys have tried it out fresh, typically it helps to teach like that, like when you have really worked on it. I think it benefits. So let me see. What was the homework? So did you guys get the vector potential part that we did in the class, correct? Okay, so and the magnetic field on it. Okay, so okay, so that's fine. So I should begin by saying because like I'm not prepared and there is limited time, by any chance if I'm not able to finish in the limited 15 minutes, then I'll probably make a solution out of it or something like that, like in the video. Unless it's, I find it very productive to go to the next class too. That's another option, but let's try to finish it off today. I'll try my best, but I cannot promise. I make mistakes too. Okay. Okay. So let's see. Which was the hard one, the Z direction or the rho hat direction or both?
Actually, the row in the denominator in the row hat direction led to, so like it didn't go to zero, there was no row left in the numerator in one of the terms. And so I didn't get it right in either direction. Because it should
Okay.
be zero in the row hat.
So neither, right? So let's start with wondering. I think the rho hat is more tough because I give a hint for that. But let's start with Z hat maybe and slowly go, right? Whatever, maybe we'll learn that way. Okay, so this is homework. So the magnetic field is given to us. So it's,
Let me get the camera moved.
oh, sorry. Because my screen is occupied with my with the PDF file. Okay, where is the Zoom? There we go. Okay, so I can announce here that I'll postpone the homework. So homework, which homework is this? 5, 6? 5. So postpone to Wednesday, I would say. So March 10, Wednesday. And midterm is March 26. Okay, well, let's see. So magnetic field. This is equation 11 in your homework. That's mu naught I over 4 pi and probably 4a. No, 2 times. Okay, first let me just copy things down. K of K. square plus rho square minus a square. Okay, plus that plus or minus, you know that. Same thing. Okay. Oh, there's a z over rho. I think so. Okay. Okay, let's see. And I give the hint that further observe that. So what that's for. So let's begin by taking this squared quantity. Let's call that, what should we call it? A1. A is usually the piece of B, C, D, C1. C doesn't show up anywhere, right? No. So let's call the C1, that's C2. So just the square bracket, not the ones in front of it. And we have z squared plus rho squared minus a squared over z squared plus rho minus a the whole square. Why am I beginning with that? Because I want to write everything in terms of k. And let's see. I need to make sure it's on the board, right? So we'll come back to this. Oops, what is it? Okay. Remember our expression, k has some values, right? So k is equal to pi by 2 times 1, helping here, 1 minus k, k square over 4.
Yeah.
And it's plus or minus?
For k it's plus, right?
Check on that.
Yeah.
It's 9 over
64.
k is 4. And e of k. I think this is minus k squared. I think this is minus again, I suppose.
Yes.
3 over 64, right?
Mhm.
Okay. So, and remember our diagram here is this is R, that's rho, that's Z, and somewhere here could be A. And what is K? Yeah, I need to know K also, right? So K was equal to K squared was 4A rho divided by R squared, no, Z squared. Z squared plus rho plus A the whole square. Okay, so let's see. What could it be? So let's try the numerator. So it's z square plus rho square minus z square divided by my idea is to write this completely in terms of k square. So we want to add and subtract, right? That's all we can do. That's equal to, let's do something. So this is z square plus rho square plus a square plus 2a rho. That is so that I can get this denominator form of the k. Okay. But all this is not there, right? So I had to subtract out. So that's minus 2a square minus 2a rho. Apparently. Let's see if this helps. And do the same thing here. Z square plus rho plus a the whole square. But that's not correct. So that involves adding. So there's a minus 2a rho here. So I added plus 2a rho, so it's minus 4a rho. So that's equal to z square plus rho plus a the whole square minus 2a rho plus a. Does it help at all? And that's equal to, let me divide this out on both sides. So that's 1 minus 2a rho plus a divided by z square plus rho plus a the whole square divided by 1 minus okay. So that at least shows me that there is a k square there. And this was the correct definition of k square, right? So that's equal to 1 here. So this is 1 minus. Let me put a 4a square there. That's k square. Times 4. That's rho plus a over 2 times rho. Right? That's correct. I can always write it like that, but I'm not sure if that's a right way to do that or not. Let me get some hints. There was some hints, right? The 1 minus k square there, 2 minus k square. a better way of doing this without, so is there a way of seeing that without this? Okay. I think that is a better way of doing it. This is surely okay, nothing wrong, but then you're left out with these rows that are, okay. Let's do the easier one first. Since we are told that the denominator or the second row hat is that, so that becomes easier. Let me try that first. It's not going good. This is z square plus rho square plus a square is equal to divided by that's equal to c square let's go the opposite way, right? Why not? 2 minus k squared divided by 2 times 1 minus k squared. Okay, since we're given this hint, 2 minus 4a rho divided by z squared plus rho plus a rho squared. And then 2 times 1 minus 4a rho over z squared plus rho plus a rho squared. Like that should be okay. And denominators can be made common. 2 times z squared plus rho square plus a square plus 2a rho minus 4a rho divided by 2 times z square plus plus rho square plus a square plus 2a rho minus 4a rho. Notice there's a slight difference between the two. Here 2 times 2, this cancels exactly the other one. But here they don't because both are having the same common. So this becomes a minus 2a rho. And that makes, so that changes it. So that's actually what we do. So that makes it the square plus rho minus a rho square. Right, which is exactly what we need. But that also gives us a hint, right, as to what might happen if this was a minus a square there. If this was a minus a square, can I not just change the sign here? If this is minus, no, then there is a rho also, right? Okay, let's do the row hat direction first. Okay, let's learn this and then we'll come back. So yeah, so this seems to be correct that this is 2 minus k squared over 2 times 1 minus k squared. Okay. Like this is probably the harder one because I give you a hint, but let me do this first once I accept this and then I can go back. Okay, so this is correct and I can erase this. Okay, so. Okay, I hope you guys are with me. Okay, so let's do C2, the second term that we had here. C2 now is equal to, now everything is in terms of K, we probably just have expanded. So this is K of K minus, this is 2 minus K squared and divided by 2 times 1 minus K squared and E of K. And we have been, there's a hint saying that we have to go all the way to K raised to 4th term. So this is, since everything has a pi by 2, I'll keep the pi by 2 all the way outside. So let's say this is pi by 2 times 1 plus k squared over 4 plus 9 over 64 k raised to 4 plus order 6. This means that this is the next term is of order k raised to 6 minus of 2 minus k squared divided by 2 times 1 minus k squared. You can actually expand this also on top. We'll do that soon. So that's 1 minus k squared over 4 minus 3 over, is it minus? This is minus, let me do this. Minus 3 over 64 k raised to 4 plus order 6. Okay. Let's process this in a minute. 2 minus k squared divided by 2 times 1 minus k squared. We want to write that as a series. So that's 2, that's 1 minus k squared over 2. That's exact, the top one. And the denominator, I expand it as a series. 1 minus k squared raised to minus 1. So that's 1 plus k squared. Remember 1 over 1 minus x is equal to 1 minus x raised to minus 1. So that's 1 plus x, and then next one will be minus 1 into minus 1, that's minus 2, but then that's a 2 factorial that cancels out, so that's plus x squared. That's minus x squared, so that's plus x squared, and so on. So that's 1 plus k squared plus k raised to 4 plus order 6. Okay. So we can drop everything to k order 6th. So let's multiply this. So it's 1 plus k squared plus k raised to 4 minus k squared over 2. K squared over 2. Next one is k raised to 4. We want to keep that. For the next term, when I multiply k squared and the k raised to 4, that's order 6th. I've dropped that, so I don't have to keep that. So one term I have dropped here. So it's 1 plus k square over 2. And this is again k raised to 4 over 2 plus order 6. Correct me if you see any obvious mistakes, because all this, anything I miss that will not match the answer. I can put this in here and then expand it out again and keep all the relevant orders. Oh, there's a pi by 2. So I have C2. I'll try to squeeze one more line in there before I switch over to the next one. Or maybe a couple of lines. So C2 is equal to pi by 2, 1 plus k squared over 4. And this is minus, let me say pi by 2, I put it right in the front. And this whole quantity is 1 plus k squared over 2 plus k raised to 4 over 2 plus order raised to 6th. And I have to multiply this with 1 minus k squared over 4. Again, when we multiply, we can drop k raised to 6. We just have to track that. So let me write it again. Multiplied form, so it's 1 plus minus pi by 2. Might be easier ways to do this. 1, expand this out, minus k squared over 4, minus 3 over 64, k raised to 4. That's the 1 multiplying all these terms. When it is k squared, I have to keep only the first 2 terms because the third one is k raised to 6. So it's plus k squared over 2. And then there is minus k raised to 4 over 8. And the last one is just multiplies 1. It's plus k raised to 4 over 2. Right? This multiplied by k squared is higher orders. Is that clear? That's what I'm doing. Like I'm just dropping, so hopefully it's not too confusing. I can collect these terms. This becomes plus k raised to 4, and this can be simplified. So let me go to the next board at this stage. So that's C2. It's pi by 2. Copying that down again. 1 plus k squared over 4 plus 9 by 64. And minus pi by 2. Minus pi by 2. 1 comes out separately. K square over 4. The k square terms, there is a 1 by 2 minus 1 by 4. That's plus 1 by 4. So that takes care of these two. And K4, there are terms like there's a 1 by 2 minus 1 by 8 minus 3 by 64. Right? That's the 3 terms coming up. Right? Minus 3 by 64 minus 1 by 8. What is that? Equal to, so that's 32 minus 8 into 8 is 64. So that's minus 8 minus 3 divided by 64. Right? So that's how much? 24 minus 3, 21 over 64. And there's nothing common in there. Right? So minus 21, no, plus 21 over 64 k raised to 4. Let me know if there is any error I'm making because it's crucial. Okay, so, okay. So that's equal to, again, sum these up down together. That's pi by 2. 1 cancels out. That's clear. So that's 1 cancels out. So k raised to 4 also count. That's good because that's why we kept the next term, right? If they did not cancel, there was no point in keeping them. So it seems that's going right. So that's 9 over 64. K raised to 4 minus of 21 over 64 k raised to 4 plus the power of 6. So that's equal to minus pi by 2, 9 minus 21, that's minus 12, I suppose. So 12 over 64 minus k raised to 4 plus or 6. Okay, so how much is this? I can do 6. This is 32. That's 3. That's 16. Right? So that's minus pi by 2, 3 over 16 k raised to 4. Does that help at all? Or do you guys know what to expect?
Yeah, that should be. I don't think that the k squared terms cancel actually.
Oh, okay. Curtis, you said you were close. So did you get the k square terms to cancel?
I deviated from you earlier, so I'm not sure. Like before this,
Tell that again?
I deviated from you earlier in the
I see.
problem, so I'm not sure.
So you didn't reach here. All right. Okay. Yeah, you're not sure. Okay, that's fine. Okay, so let's see what's the magnetic field, at least the Z component. So let's do the magnetic field dotted. No, this is not Z. Right? So which we have an expression otherwise. So that's minus of mu naught I over 4 pi times 2 over Z square. Rho, no, C over rho. Z over rho times, there's a minus pi by 2, so there's a minus pi by 2 at this point. And then there is 3 over 16. And k raised to 4, which is 4a rho square and z square plus a plus rho the whole square. K raised to 4, this will be square. Which is the same as the pi and then a square, so that we put this, try to get this together. So this is mu naught over 4 pi I times, this is pi a square, that is how I wrote this earlier, z square plus the rho plus a the whole square, and pi by 2. 2 plus half, that's pi by 2. What is remaining now? Pi is square, 4 square, 16 cancels out, so that cancels out, and 2 cancels out, and this is 3 rho z. That's it. And there is no minus sign. So I remember having seen the 3. Is this the correct question we had? It's not.
Yeah, no, that's how we got it when we picked the curl of the vector potential. the other day.
Yeah.
Yeah, that's the same thing.
That's the thing. Okay, so this works. Okay, so now the row hat is the key, right? Okay. But there probably we don't have to take. Because here it was necessary because all this second order terms cancelled out. Right? So let me see here if I can. So we this somehow, so there's a 1 minus Q square. Help. What is the expression for B? Can you tell me?
Yeah. And the redirection is mu naught over 4 pi, I pi squared z squared.
That's close.
I pi a squared times z squared. Z squared over z squared plus a squared.
So we just need Z squared.
Oh.
Isn't there one more?
Oh, sorry. That was after we set row to 0 already. I'll give you the full.
Oh. So what's that
Full,
before?
in the numerator, I pi a squared times z squared plus rho plus a squared quantity minus 3 rho times rho plus a. Yeah, this is squared plus rho plus a squared. And then don't end the bracket yet. Minus 3 rho.
This one?
No. It's still z squared plus rho plus a squared. And then minus 3 rho times rho plus a.
Okay.
And it's all over z squared plus rho plus a squared.
That's
Yep.
okay. So can I see this like this Z squared? Yeah, let me just try to keep the case square term here. I get this feeling that since I didn't mention it, the question most probably that's not needed since the time is a constraint here. Let's quickly try C1 up to k square term. So C1 is pi by 2 times 1 plus k square over 4 plus order 4. I'm just hoping that the k square term will be sufficient in this. And then minus z square plus z square minus z square divided by z square also plus a the whole square. Oops, that's row minus a the whole square. Yeah, this I have to process this, otherwise I cannot proceed. That's 1 plus 1 minus k squared over 4 plus r raised to 4. Up here. Yeah, I'm seeing this in terms of k. Okay, let me try again. C square plus rho square minus a square square. Okay. Yeah, I have to write this in terms of case. What's the same as? So that's k squared. Oh, yeah, probably that's the point here, k squared. Yeah. This is already a k squared. So that's already a k squared, but I have divided by. No. Let me write that down. So the idea is here that I have to see this as some k square function of k, then write that as a series 1 plus k square over whatever this a1 and a2 comes up, and then put it back in there and get back that. So that's the idea, but I'm not able to see this as a function of k immediately. It should be simpler than the earlier one, but I think standing on the board here, I'm not able to think. In the last few minutes.
So if you add and subtract 4a row.
Yeah, let's do, yeah, so it's something I can follow you. So 4a row,
Yeah, if you add it and subtract it from the numerator.
numerator, so this is z squared. But this is the opposite sign, right? Plus 4a row, minus 4a row.
Uh-huh.
Okay.
Because then you'll have a k squared plus some other.
This is minus, right?
Yeah, but just the 4a row part over the denominator that you have turns into k squared. Right?
Oh, I see, but then this whole thing will be the top, right? I don't gain much. Or does it?
So yeah, I'm trying to think if you can turn the row squared minus 4a row minus a squared.
Minus is bothering me, because I cannot close it as a square, right? Unless I add and subtract a row itself there. What is the trick? I'll see. It's okay, I will send you guys my notes on this, or I'll just work it out on the video. Either way, I'll send you guys. And I think I'll work out a video so that it's actually helpful, because you have finished your homework. Right? So yeah, I'll do that. Yeah. Apologies. Yeah. Sometimes you can ask a little harder ones. Something that I cannot do on the board immediately. That should be hard for you guys. Yeah. So yeah, so that's understandable. Yeah. Okay. Is that not fair, right?
Yeah, it's interesting at least.
Interesting. Okay. Yeah, you guys are nice.
Well, I mean, it's thanks for asking how the homework went.
Yeah. Okay. Yeah. Okay, good that you guys pointed out. Yeah, let me. Yeah. I get this impression that this is not that bad, and I'm just struggling here. But yeah, because otherwise, typically I give you this for the other one too. Since I gave a hint only for the type. No excuses. If I cannot do it, then students cannot do it too, or it will be much more hard for them. Yeah. Okay. Okay, let's stop, and yeah, today was not good, but still, hopefully it helps. Like I think what I've noticed is that when you guys are stuck and then you come back, even whatever I do on the board, it's more useful than teaching and new stuff. But if I had done it, probably it would have been much more useful. But I'll work it out and send it to you guys. Okay. Okay, thank you. And thanks for being tolerant.